Greetings, we are here with you in this session with the power supply repair training, and first we want to do two important things. One is to introduce the colors of the power supply wires to you in more detail, and also what output voltage each color has, and in fact, this way you will learn what output voltages a computer power supply provides as stabilized output voltages. You will also get familiar with the wire connectors of the power supply's output, and you will learn which output voltage each of these connectors provides. In addition, for working with and repairing power supplies, it is absolutely necessary that we absolutely use a test lamp in my workshop, and here in a very simple way. We will teach you how to make a test lamp. Alright, first let's take a look at the color of the power supply wires, as you can also see in this image. First we have the black wire, that is the black wire, which is ground and has no voltage, and in fact it's the negative wire. The orange wire in the power supply is 3.3 volts. If you measure this voltage with a multimeter, it might not be exactly 3.3 volts and could be a little higher or lower, which is completely acceptable and not a problem, and it doesn't fall within the range of errors. Since you are now familiar with a device called a power tester, if you use a multimeter to measure the output voltage of the power supply, in fact you tested it and saw that it fluctuates a little, you can very easily use a power tester to make sure whether this voltage fluctuation is actually outside the acceptable range. In other words, whether the voltage is within the acceptable range or if there's a problem, because the power tester shows this to you much more accurately than a multimeter. But as mentioned before, if it fluctuates a little, for example, if 3.3 volts varies between 4 volts and 3 volts, you can't really call that a problem because it's natural. In the real world, power supplies don't deliver exactly the output they're supposed to in theory, because after all they're dealing with physical issues. For example, the orange wire. In fact, the orange wire is 3.3 volts as you can see here, and the red wire is the positive 5 volts. Be sure to pay close attention to whether the power and output voltage are positive or negative. So the 3.3 volt wire is positive, the red wire is positive 5 volts, the yellow wire is positive 12 volts, and the blue wire is negative 12 volts. As you can see here, we come to the green wire, which is labeled power on. The green wire is the one that you can actually, if you connect this wire to the ground wire or one of the black wires, the power supply will turn on. When you want to turn on the power supply outside of the computer, all you need to do is connect the green wire and one of the black wires together, and in this way the power supply will turn on. That's why I called it power on, but even this green wire itself, if you measure its voltage, it has a positive 5 volts, which you can see for yourself. As for the purple wire, which is one of the auxiliary wires, it's the standby wire that carries a positive 5 volt. As you can see in this image, it says 5 volts positive standby, which is the purple wire. The gray wire is the power good wire, which indicates the health status of the power supply. It basically provides that information. We also have a brown wire, which is a 3.3 volt sense wire, and the white wire is negative 5 volts. This white wire is present in some power supplies and absent in others. So if you don't find a white wire in your power supply, it just means your power supply doesn't have the negative 5 volt white wire, and that's not a problem. Although later on in the course we will teach you how to, in fact, when you need the negative 5 volts and your power supply doesn't have it, how can you create this negative 5 volts yourself and add the white wire? This will be taught to you in a separate lesson outside of the main power supply training. So here you've seen the power supply wire colors and the output voltage wires, and you can see how they are. Now let's move on to the connectors to see what outputs the connectors actually have. As you can all see here, let me enlarge the image a bit. If we consider the power supply connector, it's the same connector you see in this image and also here in this corner. Take a look. I'm placing the image of the connector here so you can compare it with this connector. This is our power connector, and as you can see here, the first two pins are actually the 3.3 volt pins. The issue here is the ground, which is basically the same as earth. Here you can see the positive 5 volts, and the positive 5 volts are repeated again here. Notice that the output voltage is repeated several times. For example, the 3.3 volts, you can see here there are 3 of them. 3.3 volt outputs are placed here. Then there's power good, which is the gray wire, and standby, which is the purple wire. It's right here. If you pay attention, the purple wire is only present here once. Inside these wires, the positive 12 volts is repeated twice. You can see this is the overall structure of the power socket here. There's a green wire here, which is actually the power on wire, or the one used to turn on the power. Pay attention to that. In the socket there's a green wire, and next to it there's a ground wire on both sides, here and here. If you want to turn on the power supply outside of the computer, all you need is a tweezer or a very small piece of wire. You just need to connect the green socket to the black socket, in other words, connect these two together, just like you see in this picture and here. In this way, your power supply will work outside of the case. In fact, the computer will also turn on, and you can run your test and check it with a multimeter. Now, in power supplies where there is no white wire, this section is empty, meaning the socket is there, but no wire is connected to it. That same -5 volts, which is the white wire, and as you can see here, you can very easily compare it with the image shown here and see what outputs the power supply socket has. It's very complete and clear. Alright, now after this we'll continue. Let's move on to how to make a test lamp, so you can learn how to build a test lamp yourself. As mentioned, the test lamp is one of the most important tools for repairing power supplies. That is, if you haven't made a test lamp, you shouldn't attempt any power supply repairs at all. Because not only could you hurt yourself, but you might also damage your home or workshop equipment. Because if, for example, you want to repair a power supply that a customer has brought to you, and that power supply has a short circuit, and you connect that power supply directly to the electricity, the circuit breaker will definitely trip, and it can cause very serious damage. It could cause major damage to the electrical system of your workshop or home. That's why you should use a test lamp. Be sure to use it, and I'll show you the simplest way to make a test lamp. I'll explain it to you here. Although, if I remember correctly, on our website, in sessions 3 and 4, we have training on basic electronics. Of course, it's also published on this very website, where you can learn how to make a test lamp. And one of the prerequisites for learning power supply repair is that you should know electronics. So first, you get a power cord, as you can see here. Once you've prepared the power cord, we also need a bulb, and it's better to use at least a 200-watt bulb. My suggestion is that you even use a 300-watt incandescent bulb, as shown here. So everything we need is basically a power cord. As you can see here, we have a bulb along with its socket, and the bulb should be at least 200 watts. Again, I repeat, if you can get a 300-watt bulb, that's much better. But if you don't have access to that, at least use a 200-watt bulb. Do not use a 100-watt bulb under any circumstances, because the bulb itself won't let you turn on the power supply easily. So get a 300-watt bulb along with its socket, and then, as you can see here, proceed like this. Carefully strip the insulation off the power cord without damaging the wires inside or this part. As you can see in this image, remove the black insulation like this after you've stripped it off. If your power cable only has 2 wires inside, then that's fine, we don't need to do anything. But if it has 3 wires, as you can see here, usually the yellow wire is the one which actually serves as a secondary ground, and we don't need to do anything with the yellow wire at all. So, just ignore the yellow wire. If your power cable looks like what you see here and has 3 wires, if it only has 2, you'll learn how to handle that in a moment. So, if you have 3 wires, it's better to ignore the yellow wire inside your cable, because we're actually working with the blue and brown wires. Now, the shade of yellow might be lighter or darker, it doesn't really matter. Basically, we don't do anything with this wire. Alright, next, let's move on to the 2 wires we're going to work with, the brown and the blue. What do? We actually cut one of these wires. Look, as mentioned before, just ignore the yellow wire out of these 3. It's as if it doesn't exist. Out of these 2 wires, we leave one intact and cut the other. For example, here I'm going to cut the brown wire. Like this. Look, we take these 2 wires and cut the brown one like this. After we've cut the brown wire, we strip the ends of the wires, just like you see here, and in the end it will look like this. Stripping the wires, and actually this wire has nothing to do with the lamp socket, and everything we've done is wrong. In this way, a device is created, which is called a test lamp, and actually one of the wires is cut and connected to the lamp, and then comes out the other side so you can connect it to the power. Now, what does the test lamp do? For example, if you connect a power supply to this wire and use the test lamp to turn on the power, if that power supply has a short circuit, what happens is that the circuit breaker won't trip anymore, and even the power supply itself won't be damaged further, and the lamp lights up. So if you connect a power supply to the test lamp and the test lamp lights up, it means that the power supply has a short circuit, and you should never connect it directly to the mains power. If you connect a power supply to the test lamp and the test lamp does not light up, it means that the power supply does not have a short circuit or internal connection, and you can work with it more easily. The purpose of the test lamp and using this device is to prevent a power supply with an internal short from developing further problems. or for the circuit breaker to trip completely so we can work safely. Now, to test your test lamp after you've built the test lamp, we use a tweezer or a piece of wire to connect these two parts together. That is, first we plug this wire into the power and then we connect this part using tweezers or a piece of wire like this, and as you can see, the lamp lights up, and when the lamp lights up, it means our test lamp is working properly and is in good condition. And just like that, you can make the test lamp yourself, and I recommend and repeat again that you definitely do this. Well, in this session you also got familiar with the power wire colors and its output voltages. You recognize the socket, and you also learned how to visually make the test lamp. Now that our test lamp is ready and you've learned the voltage and output of each power wire color, let's move on to troubleshooting the power supply and the first troubleshooting step we'll do in the next session, so you can learn how to start checking the power supply from the beginning. First we'll troubleshoot it and then repair it. In this training series, we've considered the faults as case studies, and these are the same issues that power supplies usually encounter most often, and customers come in for power supply repairs because of them. Since everyone's goal is for you to be able to easily and quickly get started along with this training, to earn income and handle power supply repairs completely in a practical way,